The question states a block wall 100 feet long and 7 feet high will be constructed using blocks that are 1 foot long and either 2 feet long or 1 foot long. No blocks may be cut. The vertical joins in the blocks must be staggered as shown, and the wall must be even on the ends. What is the smallest number of blocks needed to build this wall? So first, if we start by listing our givens, we have that the first row must contain blocks that are 2 feet long, and they're going to be placed horizontally. For the second, we know that the second row starts with a 1 foot block, and it's going to be followed by a 2 foot long block, and it's going to end with a 1 foot block as shown. And now if we look at the figure we have here, this is a 2 foot block we have. 2 foot block, and we start in the second row with a 1 foot block, followed by two 2 foot blocks and then a 1 foot block here. So if we look at the first row, row 1, we have that the number of 2 foot long blocks are going to be, we have 100 feet long wall, so we're going to start with 100 divided by each block, which is 2 feet, so we need a total of 50 blocks for the first row right here. Now for row number 2, for row 2 we start and end with a 1 foot block as shown. So we're going to start and end with the 1 foot block, so the remaining length in it is going to be 98 feet, since we had a 100 foot wall minus 1 at the ends. So 90 feet for the middle blocks we have here. And then the number of 2 foot blocks for the in-between lengths we're going to calculate by taking 98 divided by how long each of these blocks are, which is 2 feet. So we have a total of 49 blocks in the middle. Now the total blocks for the second row is going to be 49 blocks that we had. Those are the 2 foot blocks, and then we're going to add 2 blocks that are 1 foot, since we had these right here. So to make it clear, this is the 2 foot blocks plus 2 more blocks, the 1 foot blocks at the ends. So we have a total of 51 blocks for the second row. 51 blocks. And we had 50 blocks over here for the first row. So now to calculate the total number of blocks that we need, total number, we're going to take the number of blocks in the first row, which we had was 50, and the number of blocks in the second row, which we also had as 51. And since we had the total number of blocks for all 6 rows we're going to need to calculate that, the total number of blocks for all 6 rows, we're going to take the number of blocks in the first row and add it to the number of blocks in the second row. So we have 50 plus 51, and then we're going to multiply it by 3. And that gives us 303, because there are 3 repetitions of this pattern. So we have this pattern, and then another pattern, and then another pattern. So we have 303 blocks for the total number of blocks in the 6 rows that we have. And then to calculate the total number of blocks for the wall, which includes the blocks for the 7th row, so the total number of blocks of the wall, we're going to take the total blocks for the 6 rows that we calculated here, which was 303, and we're going to add the number of blocks in the first row right over here. So to do that, we're going to do 303 plus 50 from the first row equals 353 total blocks for the wall. So our answer is going to be D,